Okay, I'll share my screen. Hope that you have got the tutorial. Maybe it came last moment. Then most of you couldn't try it. You didn't have enough time to try this one. Anyway, shall we start to answer these questions? Okay, first one, we have to find the total resistance of this circuit. You can see that all these resistors these sides are connected together. Then these 1, 2, 3, 4, these 4 resistors are connected in parallel. Okay. Then total resistance is 1 on RT equals 27 plus 1 upon 33 plus 1056 plus 1047. Are you allowed to use the calculators? Hello? Can you use the calculators at the examination?
Yes, sir.
Okay, then there is no problem with this type of problem question. You can directly use your calculators to find the answers. Okay, this one. What do you think about this one? You can see this connection. This one. So, well, wire. Then because of that, you can see this 3 ohm, 7 ohm, these two resistors are parallel. This 2 ohm, 8 ohm, these resistors are again parallel. Okay, we can redraw this starting from these 2 points. Then we have 8 ohm resistor there. And from this 8 ohm resistors, you have this 2 ohm resistors connected. So finally, when you consider the other two terminals of this 8 ohm and 2 ohm, this one and this 8 ohm, you see this connector They are in parallel. Okay. And here this is 3 ohm resistor and 7 ohm resistor is again connected to the other end. Okay, then equals 8 ohm 2 ohm resistors parallel and 7 3 they are parallel.
Excuse me, sir.
Yes.
In that previous question, can we divide that, make that 8 ohm 2 plus 7 is parallel to 8 ohm like that? Can't we get like that?
Sorry, I couldn't follow you. That you mean that 8 ohm resistor with which one?
In that one, the addition of 2 plus 7 ohm, sorry, not ohm, 2 plus 7 is 9. 9 is parallel to 8. Can we get like that and complete the question?
No, the problem is that when you consider this 2 and 7, this 2 ohm resistor is connected to this the other side of this 8 ohm resistor.
Okay.
7 ohm resistor is connected to the other side of this 3 ohm resistor. Then you can't take straight away 2 plus 7.
Okay.
So these two sides of this resistors connected together, but the other sides they have been connected to the different end.
Yeah. Okay. Now I got. Thank you, sir.
This one is not a difficult question. It's very easy one. Total resistance. All the resistors are in series. Then you can add everything together. R1 plus, R2 plus. then we can find the current going through this circuit, and this is the direction this I is going. Then I equals 300 volts divided by 18.15. If you haven't done this one, can you spend a couple of minutes to do this? Have you tried this? The current of the circuit. How can you find the current of the circuit? Actually, to find the current of the circuit, then you have to find the total resistance. And if you know the total resistance, then you can find, applying Ohm's law, you can find I. But here, we can't calculate because R we don't know. Okay. Then, but with this one, this 1K ohm resistor, with this 1K ohm resistor, we know the power consumption is 100 milliwatt. Okay. Then for wattage, what are the equations we know? VI, but we don't know then we can substitute this V using, yeah, then this W equals I squared R. Okay, then I squared equal W means 100 milliwatt, R is 1K, and this is 0.1 watt, and this is 1000. Okay. You can take this one into 4 zeros, then milliamp. And this is the current of the circuit. The total resistance of the circuit. Okay. Then you know current I is okay. V voltage we know. Then we can find the total resistance. Total resistance we divide by I. V is 130 volts. I 0.01 amperes. 30. And this is 130. You can take another zeros. Then this is 13K. Okay. If this is 13K, then other three resistors, 3 plus 4, 7, 8. 8K ohm resistor. RD equals, this is third part, and this is second one, this one. Okay, the third one is total power delivered by the battery. Third one. The voltage, total voltage, VI, V is 130 volts into 0.01 amperes. Okay, then this is 1.3 watts. Okay, fourth one, we have to find resistance. This R total we know is 13K. This is equals to 3K, 4K, 1. It's 5K. Okay. Then fifth one, the voltage drop across each resistor. If we take this one, R1, R2, R3, and this is R. Then V R1 we can find 3K into what's the current, 10 milliamperes. Current. Then we can cut this K into milliampere. This is 30 volts. VR1. Then VR2, 4K into 10 milliamperes. Then it's 40 volts. Okay. VR3, 1K into 10 milliamperes is 10 volts. VR 5K into 10 milliamperes means 50 volts. Okay, altogether 30, 40, 70, 80 and 130 volts, the total voltage. The voltage, the dissipation of each resistor. The power dissipation of each resistor. Sixth, we can find W R1. Voltage is 30 volt using VI. Then this is 30 volts into 0.01 amperes. Then wattage is 0.3 watts. WR2 is 40 volts. Voltage is 40 volts. 40 volts into this one, then it's 0.4 watts. WR3, it's 10 volts into 0.01 amperes, then it's 0.1 watts. The voltage of resistor R, it's 50 volts into 0.01 amperes, it's 0.5 watts. Total voltage is 1.3 watts. Now, when we consider those things separately, again you can see the total one is 1.3. Then we have to calculate the energy. E is W T. Wattage is 1.3 watts. Time period is 18 hours. 18 hours. The voltage given here is so why we can't use P to find why we can't use P equals IV to find directly, to find which one? Then 5.4 watt hours. Why can't we use to find directly first one? The question is asked that why we can't use P equals IV to find directly first one. What is first one? This one. Then here, because if you want to use this equation, if you want to use this one, then we have three things: W, V, I. We know W. W is 100 milliwatt, but we don't know about this I. We don't know about this V and I. Okay, but only the thing we know the resistance. This one we know. This is 1K. But we don't know what. That's why we convert this equation to I squared R. Then we know I. Sorry, we don't know I. We know W, we know R, then we can find I. Is it okay? Because here this P, this 100 milliwatt, this is the wattage of this resistor. Not the entire thing. Then we have to use this resistance, this voltage, and this voltage and current. But we don't know the voltage across this resistor. We know the battery voltage, that it is applied to all four resistors, not only this one. Okay. This one we have to convert This one into joule. Then 5.4, we can convert this one into minutes, then seconds.
Excuse me, sir.
Yes,
Sir, 1.3 into 18 is 23.4 now.
sorry, sir. Actually, I took it 3 times. Sorry. Thank you. Is it okay? Okay. Shall we find the Thevenin equivalent circuit for this one? Then we can consider this is point node A and node B. Then after removing this resistor, we can redraw the circuit. This is point A. And this is point B. $40 ohms. This one is 12 ohms. This is 10 ohms. This is 50 volts. Okay. Then we have to find Thevenin equivalent circuit for this part. then we can find RTH. To find RTH, what we have to do, we have to short circuit this voltage source. Okay, can you try these questions? That there is a problem here that this touchpad, I'll get it corrected. Until that, you can try these questions. Okay, we can redo the circuit. Then voltage source is not there because we have to short circuit it. Ten, 40, 12. Then by looking at this side, we have to find RTH. Okay, then finding RTH here, to find RTH, then RTH here, as you can see, this 40, 10, those two resistors are parallel and this one is series. Okay, then 40 into 10, 40 plus 10, 12, then 400 divided by 50, it's 12. It's 20 ohms. Okay, then we have to find VTH. VTH is fifty volt. VTH is VAB, open circuit voltage across A and B. Then to find that one, and we can mark I here. Then here you can see this I is going through this loop only. There is no way to go this I to this direction. Then if you consider VAB, actually VAB is the voltage across this resistor. Why? Here, this path, this I is 0. I put this I1 here, I is 0. Because of that, there is no voltage drop across this resistor. Then the V is also 0. Okay. Then here, across this resistor, voltage is 0. Then VAB is directly the voltage across this resistor. The voltage across this 12 ohm resistor is 0. Why? There is no current going through the resistor. Because of that, there is no voltage drop across the resistor. Then VAB should be definitely voltage across this 10 ohm resistor. Okay. Then if you find I, we can write equation 50 volts, 40 into I plus 10 into I. Then I is 50 divided by another 50. This is 1 ampere. Okay. Then voltage across this VAB. VAB is 10 ohms into 1. This is 10 volts. That is VTH. Okay. Then we can draw Thevenin equivalent circuit. Resistance is 20 ohms. This is point B, this is point A, and this one 10 volts. We can add the removed resistor here. That is 30 ohm. Then we can find IL. IL equals 10 volts divided by 20 ohms plus 30 ohms. 10 divided by 50. Then it's 0.2 amperes. Is it okay? This one. And this is point A and B. Then we can remove this resistor here. Okay. Then we can redraw the circuit. This is point A. Point B. This is 90 ohms. This is 30 ohms. And this one 40 milliamperes. Okay. In the previous case, here we are going to find VTH. Now this one, we are going to find RTH here. To find RTH, we have to redraw the circuit. Then you can see that this should be open circuit. And after open circuit, it means that there is no current source here and there is no resistor involving to the total resistor count. Then we can draw the circuit. This is point A. And this is point B. 30 ohms, 90 ohms. From this end, we have removed the current source by open circuiting it. Then there is no involvement in the circuit. Then we have to find this RTH by looking at this side. Then RTH is 120 ohms. To find VTH, this is point A. Point B. And this is the current source. It's 40 milliamperes. This is 90 ohms. And this one 30 ohms. Then we have to find VAB, then that is VTH. But this time also you can see the current going through this path is 0, then voltage across this one is 0. Then you can take VAB directly across this resistor. Okay. Then we can mark current here. Then this 40 milliampere current is going only through this resistor. Then we can calculate the VAB. VAB equals 90 ohms into 40 milliamperes. .6 volts, that is VTH. Then we can draw the Thevenin equivalent circuit. This is 120 ohms. This one 3.6 volts. And we can add the remote component here. That is what is the value? Is 60 ohm. Okay. 60 ohm resistor there. Then we can find current going through it. IL equals 3.6 volts divided by 120 ohm plus 60 ohms. 3.6 divided by 180. Zero 0.02 amperes or 20 milliamperes. Okay. This one is a little bit different question. Here, this is point A and this is point B. Shall we redraw the circuit? And this is point A. And here we have a battery. This is point A, point B, 1K, 8 volts, 6.8K and 1.2K. Okay, then we can find resistance of this one. To find RTH, we can redraw the circuit after removing the voltage source. When you look at from this end, you can see this RTH is 1K plus, this is 0.8K and 1.2K, they are parallel. Then 1K plus. RTH is 2.02K. Okay, then we can redraw the circuit. Okay, then we have to find voltage across these 2 points VAB. Okay. Then we have to mark currents going through this one. Then we can find this current I. And here across this one, the voltage is 0. Then there no point of finding this voltage. Then if it is possible to find, because that then if it is possible to find voltage across this point B and this point, that is VAB. Then if you find the current going through this 1.2K resistor, that is VAB. Okay. Then shall we find this one? This 8 volts equals 6.8K I plus 1.2K I. Then I equals 8 divided by 8K. Then it's 1 milliampere. Okay. Then if you find voltage across this one, actually the real voltage across this resistor is coming in this direction. Why the current is going this way? Okay. Then this voltage is 1.2K into 1 milliampere. Okay. Then this V equals 1.2K into 1 milliampere. Then it's 1.2 volts. But you can see VAB is not this. VAB is minus this one. The other way, VAB is minus V, then minus 1.2 volts. Did you understand why this VAB, this V is minus? Because VAB should be, we are pointing out this one, the point A is coming here. Then if we mark VAB here, VAB is other way. Because this is point B. This is point B. Here point B. Okay. Then this is point A. Then VAB is this way, but this voltage we are receiving is in the other way. Then VAB equals minus V. Okay. Then this is VTH. This one finding VTH. Then we can draw the Thevenin circuit. This is point A. And B. This is minus 1.2 volts. Resistance RTH is 2.02K. This is 2.02K. And we can, at the component we have removed here, that is 1.2K. And the current going through it is IL. Then we can find IL is minus 1.2 volts divided by 2.02K plus 1.2K. It's minus 0.37 milliamperes. RL is 1.5. RL, sorry, it's 1.5. Yes. It's 1.5. Then this is 1.5. Okay, this one. This is the point A and B. Then we can remove this. And shall we redraw the circuit? This is point A. This is point B. $50K, $20K, 100 microamperes. Shall we find RTH? To do that, we can redraw the circuit again. Then we have to open circuit this current source, then we don't have this branch here, then the actual resultant circuit is this point A, 20K, this is point B, this is 50K, and we are looking at this side to find RTH. Then RTH is 50K plus 20K, it's 70K. Okay. Then we can find VTH. For that, this is 100 microamperes. And we can find VAB here. Then we can mark, sorry, the other way. The current going through this one, this is I, is 100 microamperes, but here the voltage is 0 across this resistor. Then you can take VAB, the voltage going across this resistor. Okay. But here VAB is, because we are expecting VAB from this direction, but the current is going the other way. Then this voltage actually appeared this way. Why current is going this way? Then voltage should be the other way. Then we can write this is minus V. Because of that, this is minus 50K into 100 microamperes. Then this is, you know that this is 50K, that means 10 to the power 3. This is microamperes. Micro means milli, micro, and 10 to the power minus 6. Then it's minus 3 is remaining. Then this 100. Then again, this is minus 5 volts. And this is VTH. Okay. And we can draw the Thevenin equivalent circuit here. This is point B, point A. Thevenin voltage is minus 5 volts. Thevenin resistor, RTH is 70K. Then we have to add the removed component here. The value of that one is 180K. Then we can find current going through it, that is IL. Okay. Then IL equals minus 5 volts divided by 70K plus 180K. Okay, this is the last one. You have to redraw the circuit. You have to redraw the circuit. Then before we find anything, that we have to identify the component to be removed. Then we can remove this. This is the point A and this is the point B. We can remove this RL, and after that we can redraw the circuit again. Okay, sorry. And you didn't hear that the explanation I have given for this RTH 16 ohm. My mic was muted. Then with this 24 ohm resistor, we have, with parallel to this 24 ohm resistor, we have conductor. Conductor is a zero resistance. Then when we have this two parallel connection with this conductor, this 24 ohm contribution is not coming here because current is not going through a resistor when there is no resistance path is there. Then it's 16 ohm. Okay. Then we have to find VAB here. VAB here. Then directly we can't find VAB, but if you know the voltage, we know the voltage across this battery, but if you know the voltage across this path, across this current source or across this 16 ohm resistor, then we can find VAB. Okay, we can mark current, this 2.2 ampere current is going this direction, and this is 0.2 amperes, and current is going this direction. Because of that, the voltage across this one is in this way. Then we can find V is 16 ohms into 0.2 amperes. Then 3.2 volts. This voltage is in this direction. Okay. Then VAB is 2.4 volts plus V, 2.4 volts plus 3.2 volts. Right. Then 5.6 volts. That is VDH. Then we can draw the Thevenin equivalent circuit. This is point A. Point B. And RTH is 16 ohm, is 20 ohm to 50 ohm. This is 16 ohm. It's a variable resistor. And this is 16 ohms. And we can find then this is IL. We can calculate this IL for two cases. When RL is 20 ohms, when RL is 20 ohm, we can write the common equation for finding this IL. IL equals 5.6 volts divided by 16 ohm RL. Then IL 5.6 volts, 16 ohms plus 20 ohms. 5.6 divided by 36. Then it's 0.15 amperes.
Excuse me, sir.
Yes.
How did we get VTH as 5.6 while we are adding 2.4 and 3.2 to find VAB?
I can't hear you properly.
Sir, why did we get VTH as 5.6 by adding 2.4 and 3.2? My question is why adding 2.4 and 3.2?
Sir, the actual reason is that we have to find this VAB to find this point voltage across these 2 points. We should know this voltage and this voltage. Okay, if I put this one is V1, this is V2, then VAB is actually V1 plus V2. Okay, but we don't know the voltage across this one because it's a current source. We don't know the internal resistance or whatever the thing. But if you want to find V2, that when you find voltage across this resistor, that is also V2. Okay, then this V2 equals V. Okay, that's why I want to find this voltage across this one. Then we can substitute this V2 by V. Then this one should be V1 plus V because of this.
Okay, sir. Now I got it. Thank you, sir.
When RL is 50 ohm, then we can find IL 5.6 volts, 16 ohms plus 50 ohms. 5.6. This is 66. It's 0.84 amperes. Any question? Anything? Anything? Any question? So today is the last day. I think it's not like previous classes that now we are doing most of the time that the lectures we are doing online. Then I think we haven't seen each other. That's why I turned on the camera, at least that you should know that. Anyway, that is a nice experience with you. I think for nearly 5 weeks, we had this connection, and maybe for the next semester also, we are meeting again to do your digital electronics section. For your examination, I think you can follow all the past question papers, the past papers. Then the same format of question you are receiving this year also. I don't remember the exact one. It may be 1.5 question or maybe 1 question. Anyway, that this Severin part is having a large contribution. It may be half of the workload. If you give me. Yes, it's a half of the question. You have 1 question from circuit theory, and first half of the question will be covered by the normal theorems, and we have used that to calculate the currents and voltages across the component and the okay. Then if you have any question, that you have my email address and the telephone number. Thank you very much for your participation and contribution, and we will meet sometimes, that we'll meet you again, and hope you very good. You can do very good at your examination. and good luck at your examination. Thank you very much for your participation and your kind cooperation. Thank you.
Thank you, sir.
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 You're welcome.